Hi there, Mr. Rohrback again. This is section 6.5 of your geometry text, trapezoids and kites. A trapezoid is a quadrilateral with exactly one pair of parallel sides. Notice we've departed from the parallelogram, which we've been doing for a while, where you had two pairs of parallel sides, like that. Now you only have one pair of parallel sides. These two sides are not going to be parallel if it's a trapezoid. A trapezoid has bases, base 1, base 2, or vice versa. Doesn't matter which is 1 and which is 2. And so it has base angles. These two would be base angles, or if this we consider to be its base, these two would be base angles. A trapezoid can be isosceles if these two sides are congruent. If not, it's just a plain old trapezoid. All right. Oh, it has legs also. These are the two legs. Okay, a trapezoid, if a trapezoid is isosceles, then each pair of base angles is congruent. Therefore, these two angles are congruent, and these two angles are congruent, because if you look at it this way, these two are base angles. If you turn it upside down, these two are base angles. All right, base angles are congruent if the trapezoid is isosceles. If a trapezoid has a pair of congruent base angles, then it's isosceles. So if either of these pairs of angles is congruent, then these two sides are congruent and it's an isosceles trapezoid. And a trapezoid is isosceles if and only, if and only if its diagonals are congruent. Notice then, so if this diagonal and this diagonal are congruent, then it's an isosceles trapezoid. All right, let's see. A midsegment. A midsegment of a trapezoid is a segment, and this is not necessarily isosceles, that is drawn between the two midpoints of the sides that are not the parallel sides. So this is a midsegment. Now, a midsegment has a couple of features. It's parallel to the base, and it's 1/2. It's 1/2 the sum of the two bases. So, first of all, it's parallel to these bases. And let's say this was 14, and this was, let's say, 20. So this midsegment is going to be 1/2 the sum of those two. So that's 34 divided by 2. The midsegment is going to be 17. Notice something, by the way, about the formula for the area of a trapezoid, which is area equals 1/2 the height times the sum of the bases. Okay? Isn't 1/2 the sum of the bases the midsegment? So actually the area of a triangle could be viewed as the height times whatever we want to call the midsegment, m, or whatever letter you want to give to it. All right, we have two theorems about kites, and one of those is, let's draw a kite here, like this. Remember, a kite is a quadrilateral with two pairs of consecutive congruent sides, but opposite sides that are not congruent. That is, these two are consecutive sides and they are congruent. These two are consecutive sides and they are congruent. But opposite sides, as in, just a minute here, opposite sides are not congruent. So these two are opposite sides, they are not congruent, and these two are opposite sides and they are not congruent. So you can only have these two congruent and these two congruent. If you get opposite sides congruent, then it becomes a different figure, parallelogram, for example. So, if a quadrilateral is a kite, then its diagonals are perpendicular. And this one, sorry my drawing isn't perfect here, but this in a kite is going to be a right angle. And I'll show you in a moment how we're going to use that in some of the problems that we'll solve. The other one is, if a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. So that has to be these two here, this one and this one. These two are not the congruent ones. These two angles are going to be congruent if it's a kite. All right, now let's take a quick look at a problem or two here. For example, you have, let's see, yeah, let's do this one. You have a kite which looks kind of like this, kind of, and you have diagonals here and here, and remember they're perpendicular. Sorry, that's not a very good diagonal. There we go. That's really not very good. Okay, let's try that again. All right, now, if these are labeled, let's say this is a 3, and this is a 3, and this is a 2 and a 4. Now, you are asked to find the lengths of the sides. So these are going to be identical, we'll call them X, and these are going to be identical, we'll call them Y. This is the key fact right here. If these two diagonals are perpendicular, then you have right triangles all the way around. And right triangles, we're going to use Pythagorean theorem. So 3 squared plus 4 squared equals, if you know your triples, that's got to be a 5. Because 3 squared is plus 4 squared equals x squared. 3 plus squared is 9, plus 4 squared is 16 equals x squared. 9 and 16 is 25 equals x squared. Take the square root of both sides and you get 5. Technically, of course, as I was saying earlier, you do get 5 and -5, but -5 is not a realistic side length in this quadrilateral. So, the other ones over here work the same way, but we don't have a nice convenient triple here. So we have to do 2 squared plus 3 squared equals y squared. 2 squared plus 3 squared equals y squared. So we have 4 plus 9 equals y squared, or 13 equals y squared. Take the square root of both sides and you get y equals the square root of 13. Again, technically plus or minus, but we eliminate the minus because that would give us a negative side length. Okay, and then of course you can have some problems like this, and I'll do just one of them, which I did for my students in class, and that looks like this. We have a trapezoid here, looks like, that would be a triangle. Let's go over here and then down this way, and this comes across here, that's 4x, this is 8 minus x, this is x squared plus 10, and we are asked to solve for x. Well, what we know is that 1/2 of the sum of these two is equal to this. So 1/2 of x squared plus 10 plus 8 minus x equals 4x. So now let's multiply both sides by 2 to get rid of the fraction. So we get x squared plus, oops, that should be 10x. No, it shouldn't. X squared plus, let's do x squared minus x plus 18 equals 4x. I just want to put it in the correct order here so that we can deal with it as a quadratic and factor it. Minus 4x, that gives us x squared minus 5x plus 18 equals 0. All right, now let's see. We'll factor that equals 0, x and x. Let's see here, that should be factorable, but I don't remember why it's not looking factorable. Let me check that. Here's my problem. You probably saw it before I did. This was a 4x, but when I doubled everything, that should have become an 8x. So this should have become minus 9x. I subtract the 8x from both sides and I get minus 9x. All right, so this becomes minus 3 and minus 6. And so that would give us our minus 9 in the middle, plus 18 here. X equals 3 or 6 to make this go to 0 or this go to 0. And let's see here if that works. A 3, 8 minus 3 is 5. 3 squared is 9 plus 10 is 19. 3 times 4 is 12. 19 plus 5 is 24, divided by 2 is 12. That one works. And let's try the other one, which is a 6. 8 minus 6 is 2. 6 squared is 36 plus 10 is 46. 4 times 6 is 24. 46 plus 2 is 48. Take half of that, you get 24. So that one also works. So we have two answers that work. But again, please be sure to go back and check your answers. When you're working with quadratics, you may get an answer or possibly even two answers that don't work. All right, that concludes our discussion for the moment of section 6.5. When we return, and I hope to have more of a voice, we will be looking at special quadrilaterals, section 6.6, and also section 6.7, areas of triangles and quadrilaterals. Thank you. See you next time.